So your first experiment, of the left would be passive characterization using network analyzers. Basically, you will try to know how to use this network analyzer. So we'll first do calibration of network analyzer and try to measure some passive devices such as filters, antennas, and power dividers. So after this experiment, you should be able to know how to measure using the network analyzer. So the aim and objective of this experiment is to measure scattering parameters. I think you know what is scattering parameters. We'll discuss briefly in the following slides, and we'll try to measure the scattering parameters for filters, antennas, and power dividers. These are all passive devices. So in this experiment, we'll use vector network analyzer. So there are two kinds of network analyzer. One is scalar network analyzer and is vector network analyzer. So in the scalar network analyzer, you can only measure the magnitude of the scattering parameters. But in vector network analyzer, you can measure the phase also. So vector network analyzer is more advanced version of scalar network analyzer. So in order to use a network analyzer, the first thing you should be doing is calibration. You have to calibrate it. Otherwise, your results would be have high error. No? So a lot of errors will be there. So before you start any experiment using network analyzer, you should do calibration. So for the vector network analyzer, calibration process actually includes 4 steps. With one optional 5 step will not do it. So 4 steps is one is sort, open, load, and through, SOLT. So we'll do all these 4 steps for calibration of network analyzer so that we can get error-free measurements using network analyzer. So here, as you know that in the microwave frequencies, all the wires you have in the basic electronic circuits or low frequency, you should replace all wires by coaxial cables. All the connections should be through the coaxial cables. DUT is called a device under test. The device we are testing, we usually short form we put it DUT. So here the device we are testing is filter, antenna, and power divider. So this is a picture of a network analyzer, and it has many buttons here. So I think you can see it later on. Also, we'll give you a chance to know all these things. See, basically the idea is I will give you 1 week to know all these things. So Viva for your lab would be done in the next week. So I think you can see all the buttons here. There are actually 3 parts here. This is trace portion, this is support portion, this is data entry, then channel. So your buttons are classified into different groups. So you'll use only trace and data entry and this channel portion. Only these 3 groups of buttons you'll be using most of the time. So the network analyzer we are using is ZBA24. It's a very costly device. It comes around, I think we bought it, one of our senior faculty members bought it around 10 years back. It was around 50 lakhs. So it's a very costly device. So when you use this analyzer, you should actually do it with utmost care. This is called Roach and Schwartz ZBA24. 24 means you can measure up to 24 gigahertz. You can measure your scattering parameters from 10 megahertz to 24 gigahertz. You can also see that there are 2 ports here. This is port 1, this is port 2. So the detailed explanation how to use network analyzer demonstration would be given by our staff in charge of the lab, staff who is assigned for this lab. So that after my presentation, you can see that video. So this is a short connector, this is an open connector, this is a match connector. Match connector is written with the M here. You can see that short and open connector looks totally different here. So you have to know which one is short, which one is open, which one is match connector. So in the usual experiment, offline experiment, all student does these steps one by one. But now everything is online, so you'll not get a chance to do it. But we'll try to make it very clear for you so that when you come offline, you want to do experiment, you should be able to do it from this presentation, and the video will be playing in after this. Through connectors, through means your signal will pass through it. So you have two connection points, one point here, another point here. Look at the previous one, you just have only one connection point. Short connection means it's sorted. Jet load is 0. Open connection means it's open circuited. So jet load is infinity. So here you just have one connection. One side is connected, other side is sorted, another side is open circuited. Here one side is, see, all the connections are done here. Here it's a match load. Let's say your coaxial cable is 50 ohm, then you will have 50 ohm from here. But through connection, your signal will pass through it. You have two connection points here, this connection point and this connection point. These are coaxial cables. These are actually like wires you use in a basic electronic circuits. The device under test will use antenna here. This is a multi-band antenna. You have many arms here, which will actually give me multiple resonance. So this is the front view, looks like a F, and many arms are there. So every arm will have different resonance frequency. In the ground plane also you have arms. This is a filter actually designed by my first PhD student. So basically here you have a filter. Filter is basically composed of different resonators. So resonators and filters, the difference is in the filters you will have more than one resonator. So we have few resonators here, and in order to improve the filters, we are actually printing some metamaterial based structure in the ground plane. So this structure is actually printed in the ground plane so that you can improve the filter performance. So usually when you design the filter, you have microstrip plane, you have ground plane. So most of the time people design filter only in microstrip plane and they don't use the ground plane. So we actually exploit the ground plane to improve the filter performance. We print some metamaterials, inspired structures in the ground plane. This was done long time back, I think around 10 to 12 years back. So done by my first PhD student. Already 9 students are graduated by now. So this another filter power divider designed by the first PhD student. He actually used metamaterial based structures. These are metamaterial based structure. Power divider usually, see, you look at the filter, you look at the antenna, how many ports are there? You just have one ports. But see, this is a antenna array, so that's why you have two ports here. But filters, two ports. Usually antenna will have single port, but nowadays if you go for MIMO antenna arrays, you can have multi ports. So this is a filter and it has two ports, input port and output port. But you look at the power divider, there are three ports. Input port, then you give the signal to the input port. It will be power divided into these two output ports here. So now the performance of the power divider can be again improved by using the metamaterial based structure. So this structure we are printing here is based on metamaterials. And here the ground plane is shown here. So we'll try to measure the scattering parameter for all these three devices, filter, antenna, and the power divider. So what is BNA? BNA is actually used for measuring the scattering parameter. So if you go for microwave frequency, you cannot measure voltage, current, everything is wave. So at the microwave frequency, there's nothing like voltage or current. So it doesn't exist. So only for your basic understanding, you actually analyze a circuit or a device using voltage and current. But at microwave frequency, there is nothing like voltage and current. You cannot measure it. The only measurable quantity you have at microwave frequencies, high frequencies, your scattering parameters. So, and BNA is the device which will give you measurement of this scattering parameter. This is one of the most important parameters and the device you'll be using at the high frequency or microwave frequency. So now, first, before using the device, measuring the device under test, you will actually do the calibration. No? Just before that, this diagram actually gives you an idea how measurement is done using the BNA. So you have a source here. Now source is giving some signal. So that signal will be incident on the device under test. DUT, it could be antenna, filter, or let's say power divider or any kind of device. We will even do the active device such as amplifier in the next level. So DUT can be any device. working at the high frequency, microwave frequency. So now from the BNA, you have two ports. One port is the input port, another is output port. You will have to connect it with those port, one or two. Let's say if it is a one port device, you can connect with only one port. If it is a two port device, you have to connect with the two ports. So now inside the DNA, you have a source. Inside the BNA, inside the network analyzer, there is a source. That source will send some signal, which will be incident on the DUT. Some of the signal will be reflected back, some of the signal will be transmitted back. And if you measure the reflected signal, then you'll get the S11 parameter. If you measure the transmitted signal, you'll get S12 parameters. What is this S11 parameters? S12 parameters would be very clear from this diagram, actually prepared by some of my PhD students, and these slides are actually prepared by our tutors. So this is the S parameter. S parameter, see, basically the incident field we usually denote it by A1, reflected field we denote it by B1. So we have A1 and B1 at port 1. So this is a port 1. At the port 2 also we'll have B2 and A2. So A2 is the incident field and B2 is the reflected field. So now if I want to measure S11, what do? I actually supply a signal at the port 1. I do not supply any signal at port 2. So that's why I have crossed it here. So A2 is 0. So we're not supplying any signal in the port 2. We're just giving some input to the port 1. How much is the signal reflected? That would be S11. So ratio of B1 by A1 when A2 is 0 is the S11. And ratio of B2 by A1 when A2 is 0. So when we are not supplying any source to the port 2, we are measuring how much is the transmitted signal here. That will give me the S21. So the ratio of the reflected wave by incident wave is your S11 when A2 is 0. Ratio of the transmitted wave by incident wave is S21 when A2 is 0. Similarly, you can also do similar exercise. See, basically, if you have a two-port device, scattering parameter will have four terms, four elements, S11, S12, S21, S22. So you have to measure all of this if you are measuring for a two-port device. So what is S22? S22, in the S22 case, what we do is we actually supply some source to the port 2. So some signal is incident from port 2. Some of them will be reflected, some of them will be transmitted through the DUT, but we are not supplying any signal at the port 1. So A1 is 0, A1 has been crossed here. So now here, if you measure the reflected wave and take the ratio with the incident wave, what you get is S22 when A1 is 0. Similarly, if you want to measure S12, you measure the transmitted wave here, and the ratio of the transmitted wave divided by incident wave when A1 is 0 is the S12. So you can measure all the four parameters, but most of the time the device under test DUT is a reciprocal device, symmetric device, reciprocal device. So symmetric device means you look at the device from this portion or this portion, it is symmetric. There is no change. So in that case, you don't have to measure all these four parameters. You just measure two of them. The remaining two parameters will be S11 will be usually equal to S22, S21 should be equal to S12. That is possible only when your device is symmetric. If your device is not symmetric, when you look at the device from port 1 and port 2, if you have a different structures, no symmetry, then you cannot just measure two parameters, you have to measure all the parameters. For the symmetric device, reciprocal device, you can just measure two parameters, S11, S21, then others you need not measure it. So this is a procedure for measuring the device using the network analyzer. Step by step, it has been explained. First, you turn on the network analyzer as obvious. Then there's a button here at the network analyzer, which is a preset button. So let me just go back to the preset button. So preset button is here. This is a preset button. So as soon as you connect the network analyzer, put it on, you have to press the preset button. So if you have done the calibration before, you can automatically select it also. You can save the calibration. You do the calibration once and you save it. You can actually recall the calibration which has been already done also. But here we'll try to do the calibration once. So as I already told you, you will have four steps. One is sort, open, and match slot, and through. No, four steps you have to do it. So sort, open, 50 ohm load, through all the coaxial cables, all the device, we actually make it with the impedance of 50 ohms. So if I give a match load of 50 ohm, then there won't be any reflection. So we have to do all these 4 steps. See, basically, you have to connect all this. First, you connect port 1. Let's say you want to do calibration for port 1. You connect it with the coaxial cable. Then you select, let's say, sort in the menu. So in the menu, it will come up. When you start your calibration, you select the sort menu, then connect this load. Then after that, you can select the next, open. Then you can select match, and you can select through. Then you can keep on, pressing the buttons. Then automatically Analyzer will do everything for you. So basically, the measurements here using the network Analyzer is very simple. You just have to know which button to press, and demonstration would be done by the staff who is assigned to this lab. So from there you can clearly understand. So okay, so one major thing here is that port 1 is an antenna. Antenna is a port, only single port device, and filter is a 2-port device. So here, how many ports we have? We have only 2 ports. So we can easily measure antenna because antenna is a single port device. We can also measure easily filter. Filter is a 2-port device, but network analyzer, when you measure the power divider, one thing you need to be careful is that power divider was a 3-port device. So how many scattering parameters you have to measure? You have to measure 9 scattering parameters. It would be 3 by 3 matrix. So special care must be taken when you measure the power divider. So the power divider is a 3-port device, and we just have 2 ports. So we can only connect power divider in 2 ports. Third port is you cannot connect it. So what do you do with the third port? You actually connect a match load to the third port. So this is one thing you need to keep in mind when you do the experiment using network analyzer. Okay, I'll wind up here.